Okay, so with the final question about cloud and data lakes, now let's move to the second presentation, which is in similar ground. So our second presentation is by Antonio Martinez. Antonio Martinez belongs to the European sales engineering team, helping analysts and architects to design effective and resilient cloud data warehouses. He's a specialist in designing simple and robust as-a-service solution for all kind of companies. So the presentation is on Snowflake. It's an ML AI acceleration by cloud, data lake, and data warehouse integrator. So Antonio, all yours.
Is the mic on?
Mike?
Mike? Okay. So apart from Rohit, how many people in the room would like the next session to be in English? Hands up, please. That many? Okay, I guess we'll stick to English. You can ask the questions in Espanol, si queréis. So my name is Antonio Martínez. I work in Snowflake's sales engineering team or systems engineering team. And I'm going to give you a slightly different take on data lakes than you saw in the previous session. Over the next 20 minutes, I am going to argument, if not actually convince you, that data lakes are a transitional technology and that the ML and data scientists would be better served by using a cloud data warehouse than a data lake. Bad news for any of you who are currently designing data lakes, but I would urge you to at least look into this. So, where exactly do data lakes come from? First of all, we're going to see the architecture, a typical data architecture that includes data lakes. We'll then have a look at what Snowflake would propose instead of a data lake using a data warehouse. We'll back this up by looking a little bit about how Snowflake works in action. And lastly, we'll validate the thesis with a few ideas from Gartner and from the machine learning community themselves, and above all, the customers. I'm in the field. I'm only really interested in what the customers feel, not what Gartner thinks. So here you have a legacy architecture. This is kind of uncontroversial, no matter what you may think about the data lake idea. So data sources to the left, data consumers to the right, and the enterprise data warehouse. Over the last 20 years, typically Exadata, Teradata, SQL Server, lots of different options there. And usually over time, what people have done is complement this warehouse with a data lake. What's interesting about the complement of the data lake is what it's connected to. Okay, so on the left, typically you would connect a data lake to weblog data, clickstream data, anything that's data at scale. And the machine learning or data science team, which are currently obscured by the icons here, the data science or personalizar team would typically connect to the data lake. So this approach has kind of worked over the last 10 years, I would say, and it's resolved some problems pretty well, and it's also introduced challenges of its own. So first of all, the main reason to do the data lake approach at all is you're operating at scale. If you're operating at terabyte scale and so on, you have many options. You don't actually need a data lake. So typically large volumes means petabytes, but anything in the tens to hundreds of terabytes is fine. Secondly, typical enterprise data warehouses don't work well with JSON or any kind of recursive data. So typically Avro data or Parquet, not really well suited to tabular approaches. So what you would have to do in this case is, if you want to avoid, say, to a 6 to 9 month ETL in order to transform all of your recursive data into a more tabular approach, typically a data lake works pretty well. You put all of the data in and use schema on read in order to read it. And the last one is concurrency. So usually in most organizations, no one wants the new data scientists or the new innovative approach anywhere near the business critical data, okay? So that's why most of the data science or machine learning applications land on the data lake, because you have to, you told me this would happen. I should have listened. So most of the business critical approaches don't want the data scientists on the same system that is running the business critical approaches. So what are the cons? First of all, in the previous architecture, the problem is that it's a separate system, okay? Now, that's fine if you're a data scientist, but I would argue this actually slows you down, because the data lake helps you get started because you're not on the data warehouse, but it stops you getting to production, and at every point, you have to justify why your numbers are slightly different from the numbers that you're getting in a report. Secondly, what is absolutely crazy, and I'm sorry if there are any ML fans out there, is that if I change the tool I'm using, I also change the data platform. That's just crazy. So a data scientist is not only a Spark expert or an expert in specific algorithms. A data scientist will often start using a report, get a specific insight, and then perhaps use a BI tool in order to pursue the data, do a bit more data discovery, and they'll start using the predictive model last. But usually what you will start with is the data that you've already got. So it is absolutely insane to suggest that a data scientist, a real data scientist, rather than a converted algebra teacher, is someone who will have to change platform if they change to using a different tool. And lastly, no one ever cares about these guys, but believe me, no matter how much you accelerate the machine learning process within your team by using a data lake and having that separate silo, sooner or later you will have to move into production. And this is when you start getting closer and closer to production, this is when security will appear. So those of you who work in Spain, it's the LEOPD. At the European layer, it's GDPR. GDPR is typically $20 million in fine or 4% of annual revenue if you commit a violation. So it's something that the chief data officer and the compliance officer is going to pay a lot of attention to. And this is the point that the data warehouse guys have done pretty well, and yet the data lake hasn't paid any attention at all to this until you start getting ready for production. So overall, it's looking okay. You can get started, and it enables you to present a result, but I would argue that the data lake slows getting things into production down, and at some point peters out. So here is the architecture that Snowflake would propose in the cloud. It's actually more closer to the architecture you would have seen 20 years ago, actually. And the reason for this is that the warehouse idea is a pretty good idea. Everyone wants the data in one place. And the only reason to complement that with an external data lake is because the technology didn't exist 20 years ago. Cloud-based technology didn't exist in order to be able to implement a strong data warehouse function in the cloud. So what does this mean? Typically, Snowflake's warehouse will put all of the storage into object store. This means that you're getting data lake price points with Snowflake. It's around $20 per terabyte per month, compressed. And compression rates are typically very high. So storing in Snowflake is cost equivalent to storing in the object store. And each team gets a very specific amount of compute for themselves. And this is the big idea within Snowflake, to separate the compute and storage. So if you want to store a petabyte of data, but you only use it occasionally, or you have a historical use case, and you have around 7 years of data, but you only really look at the last month. I don't know about you guys, but I only complain to my bank or to my telco provider within the last month. I think if you go back to a year ago to complain about that one call you made that didn't go through, there might be a bit of a problem there. So the idea here is, in the same way that within my house, I only have the lights switched on in the sitting room to watch a film. I don't switch on the lights in the entire house and the neighbors and the whole block. And that's the biggest problem that typical warehouses have. In order to get one group of users on the system, I have to turn the whole thing on. With Snowflake, for example, what I can do is just focus on one group of users. Each of these would have different resources and different sets of compute. And I can scale up or scale down instantly by only focusing on one group of users. If I'm the ETL user, for example, I can even switch it off. So I finish my ETL overnight and I switch the whole thing off. And what it means is I'm only really paying for the granularity of exactly what I use, not the entire data warehouse, which is something you'll even see on many of the cloud warehouses provided by cloud vendors. So this architecture is pretty nice from the architectural perspective. Most architects see it and think it's fewer moving pieces. So let's see what it gets right and what it gets wrong. First of all, the same pros that we saw with the data lake approach. Snowflake is a data lake, and a good data warehouse should be a data lake. So first of all, Snowflake can store large volumes of data. Our largest customer has around 55 petabytes of data and is storing it at the $20 price point. It can also blend JSON. You should be able to do both tabular analysis and semi-structured analysis. JSON, XML, Parquet, and all of the rest. Snowflake also gets that right and makes it easy. And lastly, as we've seen before, because each user group gets their own resources, you can onboard thousands of users in parallel without hitting any contention points, which is the usual problem with onboarding too many users on a traditional warehouse. But Snowflake also gets the other challenges right. First of all, you have a single consistent data repository. So if you're the data scientist and your model says the business should do this, you're not fighting with the report or BI guys whose different numbers says it should do something else. And what's most interesting here is that as a data scientist, you're actually pulling the data once it's been cleansed, once it's come out of the same process and the same data pipeline that everyone else is going through. If you start from flat files, which I still see some teams do here in Spain, you're essentially spending most of your time doing data prep. So the data scientists in the room, the estimate is around 80% of a data scientist's time is put into data prep. Of course it is. You're implementing the ETL all over again, but for a completely different system. So this is one way to accelerate that. Second of all, what you're essentially proposing here is that everyone use the same data platform. So machine learning is suddenly seen as one more tool, and it doesn't need its own toolkit. Machine learning doesn't necessarily have to be Spark. Machine learning can simply be a more extended analytics on the traditional BI tool. The MicroStrategy, the Tableaus, Data Robot, all of those kinds of tools are starting to offer machine learning in parallel with more tabular reporting, etc. So that kind of capability should be running on large data sets, and it shouldn't necessarily involve a tool chain. And lastly, and this is the one that really accelerates getting into production, if you use a single platform, you only have to put the rules for data masking, you only have to put the role-based access control rules and so on in one place. Most organizations, securing a large-scale enterprise warehouse for thousands of users, it's pretty expensive. You need to do a lot of tests, you need to do a lot of security protocols. So one of two things happens. Either your project has enough budget to pay for it, in which case security and operations hate it because they have to maintain two systems, or you don't secure the data and you never reach production. So this is why, and someone's smiling over that, I really hope your data is secured. But those are the two realities. I mean, either it is secure or it's not, but this is the part, it's not all about performance. When we say a data warehouse can accelerate ML, it's not only that it can accelerate the ML process itself in terms of data prep, but it will accelerate actually reaching production rather than getting stuck in limbo for years on end. So I hope I've convinced you at least so far that the other architecture would be preferable. A single source of truth and a single source of data tends to be preferable as a data lake than a siloed data lake. So let's have a look a little bit into how Snowflake works. This only works in the cloud. So I know there are some fans of doing it on-premise, and you mentioned that as well. This only works in the cloud because the kind of throughput you need to do this architecture between the object store and the compute resources, you need uplinks of terabytes per second. So some of the largest networks, the largest private data centers in Spain have uplinks of around 60 gigs per second. The cloud providers in between the virtual machine instance and the object store, they're putting terabytes a second in, and that's something that's way beyond the ability of most private data centers, and it's why Snowflake is focusing on the public cloud, essentially. So typically, Snowflake has three layers. First of all, the blob store, or S3 at the bottom layer, all of the data which is already micro-partitioned. You don't need to do anything magic here. Snowflake is doing all of this for you automatically. You don't have to do an ETL. You don't have to get the partition keys right, and so on. All of the data ends up being micro-partitioned in Snowflake in a columnar store. So you alluded to that before. Analytics only works if it's a columnar store and if it's micro-partitioned so that you can do dynamic tuple pruning and so on and so forth. And all of that is secured with the various security keys. So the DDL typically sets up the actual schema itself so that you know what to refer to. And after that, what happens is that each team is going to get its own cluster. So as we saw, those of you who were in the demo before, we saw that this scaled in seconds simply because each team, whether it be BI or it be the ML team, when you ask either Amazon or Azure or Google or whatever for a virtual machine instance, it takes some time to provision. You don't get it back in seconds. But Snowflake is running massive pools of hot servers that they can switch in and out of each cluster. So actually spinning up a cluster of a different size is kind of cheap in Snowflake. And what Snowflake gets right is that, for example, those Hadoop fans in the room, one of the challenges with Hadoop is that the replicas, so which replicas are interesting, are chosen kind of early with Hadoop. Traditional Hadoop, what it would do is place through replicas on different servers, and sometimes you would get pathological effects. So, for example, lots of queries would land on the same three servers, even if you had a much larger cluster. Or vice versa, if you want to do a star schema, you need a pretty good join engine. And what a typical Hadoop installation would do is toast the network because it would need to pull the replicas from different nodes. So that's why all of the Hadoop guys and so on are saying denormalize, 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 denormalize. It's the only way to do distribution. But that's not 100% true. It's one way to do distribution if you're prepared to pay a different kind of runtime cost. But here what you see Snowflake doing is, because it has the information about the query itself, it chooses which blocks to heat up from the object store and put into the SSD disks that are running on the nodes. And that's going to depend on whether you're running a reporting and BI workload or a machine learning workload. Not everyone is going to get the same cache, and this is how concurrency works essentially in Snowflake. The other use case that we typically get asked is, how do you guys do ACID properties? So another of the great challenges, for example, with a data lake is that you end up with a bunch of files, a bunch of Parquet files, but you don't really get data consistency. You can't update more than one row. You don't get even update and delete in many, many cases. It depends on the implementation, but these are typical challenges that you'll get. And having to rewrite everything in order to keep the denormalization happy is sometimes a lot to ask. So what Snowflake allows is the loading group also gets a warehouse of its own size. And typically, all of this load will end up in the blob store or in S3. It will be micro-partitioned, mini-maxed, compressed, and so on. And what Snowflake's, all of the query management layer, what that's doing is making sure that the data is consistent between warehouses and between user groups. So typically, if someone loads data in Snowflake, either everyone gets the change or nobody gets the change. It is absolutely transactionally consistent. And this is something that means that the business will gain confidence in what the actual algorithm's using, because this is what everyone in the business is used to. You can't go back and say, hey, we ran the query, I have no idea what the numbers mean. So this is a little bit about how Snowflake works, and what it's doing in parallel is those blocks essentially synchronizing them. So the entire database has a gigantic commit log. Either all of the users are consistent or none of them are. Anyone who's working in regulated platforms, whether it be telco, financial services, healthcare, this data consistency seems like it's less important when you're just getting started. But if you want to move into production, someone is going to ask that question. How do you guarantee that this result is 100% consistent with what I'm seeing on the reports? So far we've seen a little bit about data architecture challenges, what data lake, an external data lake architecture looks like. We've seen what a Snowflake data architecture looks like, which is essentially the data warehousing architecture everyone has been using successfully over the last 20 years, but at scale. We've seen a little bit about how Snowflake can do its magic and work. I would like to provide you with a little bit of feedback about how people are receiving this in the field. So first of all, Gartner. By 2021, 70% of mature organizations will have more data flowing from data lakes to data warehouses than vice versa. So 2021 is 2 years away, so don't panic if you're just getting started with a data lake today. You've got 2 years to fix it. But what this is telling you is essentially that this idea is a trend. It's not just Snowflake. We think that Snowflake has one of the few approaches that can do the data lake function in the cloud, but this is a massive trend that we are seeing across the board. It makes no sense to put all of your analytics functions onto a data lake. And guess what? Data scientists, I love them to bits. I love them to bits, and the machine learning community I've got a lot of love for, but typically there might be 5 to 10% of the total analytical effort within any one organization. So it's important to be realistic. I think they can get some great results, but it's also important to play nicely with the rest of the teams. Gartner are great, but they are the analysts at the end of the day, and analysts' opinions change. So how about ISVs? How about the people who are actually delivering machine learning capabilities? These are a community I have a lot of time for, and if you're using either Databricks or DataRobot, a Data IQ, even more niche stuff like H2O, if there are any H2O fans in the room, every single one of these vendors has a Snowflake connector. So that tells you something, because this is being put forward by popular demand. And what they are seeing is that this kind of approach accelerates their own adoption. And this is where the magic happens, right? The magic doesn't happen in data prep. The magic happens training the model and emitting a fantastic result. So every single one of these vendors has validated the architecture, and they all have connectors to Snowflake and actively push this connector. And lastly, the customers. Devon is kind of a public use case. We have a ton of use cases that aren't public, so I can't really talk about them. But these are impressive numbers, but they're not isolated to one energy provider. We also have machine learning, for example, running with ASICs, which is another public company reference. And those of you who are runners, essentially ASICs took all of the data they had from the runners and training, correlated that with JSON data with weather conditions, and built up a model that allowed you to predict how much faster or slower you would be in a marathon, depending on whether or not, for example, it rained or was snowy or was cloudy. The model is so good, they've improved it, that they can essentially tell you that if it rains this Saturday, whether you're going to lose between 2 to 5 minutes, just because of how they blended in the meteorological information. It is actually amazing. In my case, I'm not a very good runner, so if it rains on Saturday, I simply will not turn up and lose 2 hours. But those of you who are good runners, that's the kind of modeling that you can get, and this is essentially a validation across the board, from analysts, from the ML providers themselves, and from customers who are already building this kind of system everywhere you go. You can trial Snowflake for yourselves. It's a cloud service. It's super easy to use, so anyone who would like to give Snowflake a spin can do it, and that's the URL. Questions, please. In Spanish or English? We can do questions in Spanish. No seáis tímidos, o sea, yo, de verdad, podéis hacer las preguntas en el idioma que queráis. Deutsche, parle pour français, egipcio. ¿Puede ser Amazon? Esa es muy buena pregunta. O sea, digamos, Amazon es un ejemplo. Obviamente, Amazon es la primera nube pública que se implementó, pero Snowflake actualmente corre en Amazon, corre en AWS y está en Public Preview en GCP dentro de nada. De hecho, ese es uno de los puntos que mencionabas tú antes. O sea, cuando voy a la nube, uno de los retos es la portabilidad. Lo que, digamos, quiero utilizar el servicio de nube, yo creo que da muy buen servicio, pero necesito una estrategia multinube. No la tengo que ejercitar necesariamente, sería un poco de locos desarrollar en paralelo en 2 nubes, pero necesito un plan si por cualquier motivo una nube se me queda corta. Y ese es parte del valor de Snowflake. O sea, es un data warehouse de ANSI SQL y permite réplica, por ejemplo, entre nubes y entre regiones. A escala más pequeña te puede dar un poco igual, pero por ejemplo Capital One, que es un banco retail, ellos no se pueden permitir ni una baja porque una región esté caída. Sí que ellos están haciendo réplica constante entre nubes. Y yo creo que esa tiene que ser, el movimiento a la nube, o sea, parte tiene que ser la fase 0, pero cualquier CEO necesita una estrategia de nube a largo plazo. ¿Contesta a tu pregunta? ¿Más preguntas? Todos a la vez no, ¿eh? O sea, venga, dispara.
¿Qué hay sobre los temas legales de subir los datos en la nube? En el workshop mencionaste que algunos bancos, digamos, están usando la herramienta, pero en Latinoamérica, por ejemplo, los bancos no tienen permitido subir a una nube pública.
Muy buena pregunta. A ver, en España, Latinoamérica, o sea, bueno, como decía William Gibson, el futuro ya está aquí, lo único que está distribuido irregularmente. Si me voy a UK o si me voy a Estados Unidos, tiene todo esto subido ya. O sea, Capital One lo tiene subido, tienen un CEO que dijo Cloud First y lo han movido entero. Y en el Reino Unido, por ejemplo, también se está moviendo muy rápidamente. Como dices, depende de la reguladora. Aquí en España, por ejemplo, ahora mismo los grandes bancos lo que están haciendo es trabajando con la reguladora, con el Banco de España, para aclarar cómo llegar. O sea, hace 3 años la respuesta hubiese sido no, no podéis ir directamente. Y ahora es cómo puedo ser respetuoso con los datos, cómo puedo garantizar la seguridad para poder llegar. Y lo que están haciendo es desarrollando el protocolo interno y realmente definiendo exactamente qué tiene que hacer el DPO, cuáles son los requisitos con GDPR y demás. Así que depende un poco del entorno. En Latinoamérica la cosa no está, o sea, no es todo o nada. O sea, sí que algunas de las reguladoras, por ejemplo, insisten mucho en qué regiones puedes usar y también miran mucho a la regulación europea para tomarlo como muestra. Así que depende del banco, depende qué tipo de datos, pero efectivamente esto es una conversación regulatoria y en la mayor parte de los casos cuando hablas con el compliance officer y repasas la seguridad que te puede dar en la nube, realmente hay niveles de seguridad que son superiores si utilizas Snowflake a si utilizas, digamos, el entorno on-premise. El entorno on-premise es un arma de doble filo, o sea, está en tus instalaciones, pero el mayor problema que tienes es insider threat. Entonces, hasta cierto punto, o sea, el ataque, digamos, más temido no es el que viene de fuera, es el ataque más temido es, hay una montaña de firewalls y demás. El mayor problema es alguien dentro de las instalaciones que esté observando tu dato sin ser detectado. Y en ese sentido, empresas como Snowflake o empresas como la nube simplemente hacen la seguridad a gran escala. No es que sean ni más listos ni tengan más tiempo, es simplemente que se dedican solo a eso y son capaces de replicarlo para todas las empresas del planeta. Así que, por ejemplo, el cifrado, la gestión de claves, múltiples claves, recifrado del dato, cuestiones de auditoría, todo esto te lo hace mucho más fácil un sistema que tener que coger a tu equipo de ingenieros y hacer tú la auditoría, tú el cifrado, cómo gestiono la clave, cómo meto la clave en un HSM para que rompa en caso de que alguien lo mueva, etcétera, etcétera. La mayor parte de proyectos no tienen ni ancho de banda ni el presupuesto para implementar ese nivel de seguridad. Y sin embargo, si lo haces una vez bien y lo replicas a escala, te sale casi gratis. ¿Ha contestado eso? Es que estoy trabajando con bancos en Latinoamérica también. Go for it.
Hadoop platforms, which is not data warehouse driven.
Yeah.
We have the flexibility of using storage layer depending on the type of use cases. For example, InfluxDB for time series or MongoDB for document kind of analysis. Does Snowflake gives equivalent features or performance guarantees as compared to these specific use cases of data? Or do you propose that, okay, you can integrate MongoDB and InfluxDB and Snowflake in the...
That's a good question. I used to work for Cloudera, so I think I might be able to handle this one. So that approach is kind of interesting, and it is, I think, very attractive. So what I positioned here is that a data lake is not a great idea for 99% of business data. If part of the business is doing image recognition, for example, then you wouldn't put that in a warehouse. Okay, so if you're that kind of business, you're doing image recognition, voice recognition, then I potentially wouldn't recommend this approach. But what I find is that the promise of using a single platform independently of the tool, that is such a lie. And I'm going to tell you why. I started off 5 years ago believing that that would be a very good idea. It is an awful idea. The data comes in CSV or JSON. You can't run analytics on that kind of data. You can't do search on that kind of data. You can't do NoSQL on that kind of data because it's just a bunch of files. So what everyone does is integrate they transform the data for the right service. So if I'm running Mongo, if I'm running Elastic, or if I'm running HBase, what I do is I build a massive balance tree of nodes so that I can do search and serve out on a key. But that data is awful for analytics because it is a massive hash table, a massive balance tree, whatever the index is built as. So if I try to do analytics, the queries never end. If I do the analytical thing, then I've got all of my data that's pretty compact, but I don't have strong indices in order to index it. So what you actually see in the Hadoop world or in all of the open source world is that it is such a lie to believe that a single data platform is going to work no matter what the tool, because each tool will convert the data into something that favors the service that that tool provides. So you end up with a single file system layer, if you like, but you actually end up replicating the data not once. So first of all, you've got the incoming CSV. Then you've got the Parquet transformation for the Hive or Impala queries. You've also got the edge-based copy, and then on top of that, you've also got a copy for search. So a single piece of data has a copy in 4 different formats, times 3, because that's the number of times you need it. So I think it's a great point, and I started out thinking that was a plus, but you know what? The entire market, what they're saying is what matters to me most is the service. I don't care about the data. So like when I take my motorcycle to the garage, I don't care how it's made. And everyone has a mobile phone, no one cares how it's made. What you want is a service, and I think what we're seeing in the cloud is that people will just use the service because it accelerates the project. Does that answer your question? Now's when you beat me up or throw... Okay, you're welcome.